Hello and welcome back. I'm Derek Strauss and I'm talking with Vivek Anand. This is the second of our series of interviews with Vivek. The theme of what we're talking about is revolutionizing business with data science and AI. So if you missed the first segment, go back and pick that up as well. It'll give you a good basis for what we're about to talk about. And remember that this is segment 2 and there will be a segment 3. So keep your eyes peeled for when that becomes available. Vivek, let's switch gears a little bit now and talk about data science and artificial intelligence case studies. And can you give us some examples of high-value business problems that you've encountered and how you've been able to solve them using data science and artificial intelligence?
Yeah, absolutely. So I'll give you maybe 2 or 3 examples across different industries. So basically, it kind of is a good segue into this topic from what I was discussing previously, right? So historically, well, not historically, sometime like maybe 5, 7, 8 years ago, the B2B pricing where I have worked like a great deal, we used to segment the business based on the business SME's expertise, right? So SME says hey, I think XYZ, here are the list of 7 attributes that kind of define my business, and some combination of those will create different business segments on which we need to price optimize, right? Now, and then there would be a salesperson who would come and say well, I think these are these attributes, right? So you'd start with historically what the way things were done is hey, the business prescribes segment by business on these attributes. The models used to be built that way. We segment based on what the customer is saying, right? But when I started in B2B, the data science was starting to become a more adaptable and palatable things. People were open to trying data science. So what we did was we took a list of the attributes that we got from our end customer. They're saying the salesperson says XYZ, the business sponsor says ABC attributes. And what we did is we ran our own EDA. So we just run an exploratory data analysis and just look at how the price of the Y variable or the target variable, as we call it, is varying with respect to these different attributes. Now, more often than not, I would say, there used to be a case that what the business thinks how the business operates was very different. They would assume that this particular feature, like geography, doesn't have any impact on my pricing. It's the same across the country. But when we run the data, we say okay, your pricing in California is very different from Florida versus Midwest versus New York, right? So we could see those patterns, which the business thought was not important. So these were the attributes that previously the segmentation would not happen. But with data science, we are able to assess these attributes and even show that there is a value in it. Now, so that's one aspect of it. The other aspect of it is just the scale and the speed of it. If you have hundreds of attributes that can potentially explain it, some of these that you have observed, some of these are external. How do you assess those? And that is where the new data science techniques, where you can run a quick regression of sorts. And that will give you a feature importance on that. Oh, the target variable is price. And here is a laundry list of 100 variables. Which of those 100 are important or relevant? The feature of importance kind of gives you a relative importance. It's very standard data science machine learning technique that gives you a relative importance of those features. And then you can plug that into the segmentation model. So that is something that I've done where I have used data science to assess the attributes, a good deal of those, and come up with a narrower list, which is not exactly what business wanted. But I was able to explain using the data analysis, the EDAs that I had, okay, these are the ones that matter. So that was one aspect of data science. Data science, the other aspect of it was finding hidden patterns, if you will, right? And an example that I use often, which is very relatable, is I was working with a painting customer, right? And painting customer wanted to segment the business on 3 attributes. Hey, I want to have a different price for contractors. I want to have a different price for builders. And I want to have a different price for people like you and I, the DIYers, as they used to call it, right? Mm-hmm. And what used to happen is the salesperson would come and say hey, the price for this builder is too low. It needs to be higher. We say well, here is the transactional prior builders. And they were like, that something doesn't sit well. I see what you're saying, but it doesn't make sense. So what we did is just use like something called affinity propagation, right? We ran it on that set of data and said like, okay, find me how many unique distinct clusters of types of customers are there in this customer data. Affinity propagation came and said like, well, I think there are 5 distinct clusters. Of course, you run the science and then you get it. And the business was using 3. So what are those 2? And we took those clusters and we kind of assessed like, okay, what is the difference between this cluster versus this cluster? And then we realized there were builders, but there were 2 kinds of builders. One was like the big scale home builders that build communities, hundreds of homes at a time, right? And then there's like builders who are building like apartment complex, onesies and twosies. They're both builders, but their scale is different. Their pricing sensitivity is different. So that was something that was not available in the data as like, hey, this customer is a builder. But within builders, there are 2 different groups that machine learning or data science helped us identify. And we were able to like clean the data and bring additional data to have good attributes. That is one good example of data science, like just doing a good job of segmentation or clustering or grouping similar selling situation. The other use case of data science is like forecasting. I mean, I was working for an oil and gas company, and this is something that doesn't happen often in oil and gas, is like the way you and I buy gas, we go to a gas station, buy gas. But there is something called a terminal, which is the gas station for the gas stations. So gas stations go and buy fuel from there. And that is a place where the fuel prices don't change often. Like there are 5 refiners that are selling to people, and all of them are nearly priced the same. And the situation you have is, think about you have a giant tank where everyone has put the exact same item, but they have different prices. If you are the buyer, if you go there, whom you'll buy from? You'll probably buy from the guy who has advertised the least price. So what happens is the guy who has advertised the least, the refiner who has advertised the least, is the first to sell out. The guy who has priced the highest probably didn't sell anything. So your objective in this case is to be priced high enough to sell out the last, so that you don't leave the money on the table, but you still sell it. This is a very intricate forecasting problem. Forecasting on demand, forecasting on price your competitor will have. And we have solved these problems. Like I built models that would deep neural networks, because this is like a very hairy data that exists and is available. We build deep neural networks to be very precisely be able to predict what the competition will be pricing tomorrow. And based on where your competition is pricing, you want to price yourself so that you're the last one to sell out or not the first one to sell out. And that was a revenue optimization opportunity. These things did not exist before data science was there. And then like one more simple example I'll give you that I did, this is less of a data science, more of a pricing analytics. So I was advising someone who was building like a SaaS product, and they wanted to know how to price it, right? And typically how things are done is you run a survey, and then people say like, well, I'm willing to pay $10 for this product. I'm willing to pay $15 for that product. And in that case, that usually the scientific literature or the academic literature said that there is a lowballing effect. People usually tell you the price, which is lower than what they would actually pay for. And so what we did was like, we built a structure which was based on what we call like Van Westendorp price sensitivity metric. So it would ask you 4 questions instead of 1 question or multiple questions. It will say like, okay, what is the price point where you think the product is too cheap that you'd start doubting the quality of the product? What is the price where you think it's a good deal, it's a good bargain? What is the price where you think it's expensive product, but you'll consider buying it? And what is the price point where you think it's just like, no questions, I'm not buying it, too expensive? And then you could plot those 4 curves on the cumulative of response. So the cheap and too cheap will be a downward sloping curve. So 100% of people will feel that $0 is just too cheap. And as you keep on increasing the prices, the percentage of people who think it's cheap starts to go down, whereas the expensives will keep going up. So you have a survey analytics that can tell you the range of acceptable prices where it's not too cheap and not too expensive. And some version of it can even help companies like assess like, hey, am I delivering value to the company, to my client, to my product or not? So this is more survey analytics that helps set price for initial products. So those are some use cases. I realize I'm talking too much, but like I'm happy to take any questions. I just like,
Yeah. No, those are really interesting, and gives us a nice kind of broad view across a number of different industries and applications. What strikes me is that probably in each of those cases, you had different barriers to overcome in terms of getting the organization to change and adopt this new way of doing things, this new way of, because literally you're revolutionizing the business. No longer are people making decisions based on gut feel, and they're starting to really rely on a more of a scientific approach. And I know that we touched on this point a little bit at the end of segment one. We were talking about the adoption and the importance of explainability. Kind of in a nutshell, if you were to step back and look across the broad swath of experiences you've had in all these different industry sectors, what would you say would be the number one way that you've found is most successful in overcoming the challenges of adoption of data science and AI?
Actually, a very good question. It's explainability is the first part of it. And the second part of it is change management, actually. So like, I mean, if I am forecasting, like, let's just use the example of oil and gas, right? They also do some sort of forecasting, except they use some sort of a time series. Like, there's companies that use advanced models. I'm not saying that, but the one that I was building for was using like relatively time series model, which accounts for seasonality and autocorrelations and things of that nature. But if you have a deep learning model, even if you use a transformer architecture that we use, it just revolutionizes that thing. And the way it does is like, I mean, I'll just like dig a little bit deeper into techniques. So transformer architecture is a sequence model. So I planned not to use the word ChatGPT, but I'll use it. ChatGPT is based on a transformer architecture. And what is unique and novel about transformer architecture is it is position aware. It has an attention mechanism. So basically, if you tell the dog is eating, I don't know, ice cream, other traditional data science models will use, hey, in this word, I have 10 words or 6 words. The words are the dog eating, and it treats all of them the same. The transformer architecture is able to provide context to it. It is able to understand the thing we are talking about is dog, the verb we are talking about is eating, and the object is ice cream. Everything else is not that important. These are 3 more important things, right? So what happens is it is able to capture temporal patterns. It is able to find context around things that drive prices. So the forecasting model that we built using deep neural networks, or like if you use transformer architecture, it's going to be far superior. So you're predicting something. Let's just test how your model would have performed on historical data versus how my model would have performed on historical data. So that is, again, part of it. Like, hey, just look at how superior the predictions are. That is one part of it. The other part of it is, like, again, helping people at different level of maturity in data science. Like, sometimes you just give them a visual, like, hey, here is your situation, similar to what I was talking previously, right? The other thing is change management. If you're incentivizing your salespeople or the user of analytics for something else, and your business objective to use data science analytics is Y, and they are not aligned, there's a chasm, there's a gap between it, it is going to cause problems. I'll give you an example that I've seen. So we built a data science solution for a customer, again, pricing model, and it would say, like, okay, here is a range of prices you should target. And we usually saw the salespeople who are typically getting like the lower half or lower quartile of the recommendation range. And the business sponsor was like, hey, your model is probably not doing it right. Why are people not adopting it? Why am I not getting the benefit that you said we'll get? And this was a little outside of the scope of our statement of work. And we said, like, okay, let's just look at it holistically. And we saw that the salespeople were incentivized on number of sales they made, not the profit they generated. So you have a quota to make 1,000 sales per month, whatever. Then it's a race to bottom. You are incentivizing on something that will result in a race to bottom, people offering lower prices to just get the deal done. And your business objective is to maximize profit and revenue. Those two things are not aligned.
Yeah.
And this is where the change management part comes in. So we kind of like guided them through the change management process, like, hey, instead of the deal, you also probably want to bake in a component where did that deal happen within that price range that I'd be recommending. If you're closer to the target, you get, I don't know, 200% bonus. If it is close to the floor, you get 100%. So gradual change management and transferability. I mean, two key components to adoption of data science and analytics. I mean, people love, everyone, I mean, we are human. We love the comfort of the familiar. I've been doing this thing for so long, I don't want to change.
Yeah.
Again, that's where change management becomes important.
Yeah. I'm glad you raised that, because I feel like that is the thing that we so often overlook, is the change management side of things. And some deliberate planning around change management up front is so much wiser to take that kind of route than to kind of just leave adoption to chance. So great point. Thank you for elaborating on that one. I think we're probably going to take a pause at this point, and we'll come back and address another topic in segment 3. So to our listeners, be sure to pick up segment 3, where we're going to talk about the future of data science and artificial intelligence.